welcome to a lecture series on real analysis. In this lecture, we are going to see some examples of connected sets in real plane. Let us get into the lecture. Here, we are asked to consider the following subsets of R2, and hope you remember we have considered these sets and examined for the compactness in R2. Now, we are going to examine the connectedness of these sets in R2. And I don't need to explain much about the diagram of these sets, as we have seen those things in checking compactness. The first one is going to be the thing which if we are asked, if we have taken a plain sheet of paper and have dots of equally distant dots, and this is how the plane is going to look like. Okay, this has to be equally distant, and this is our set R2 minus I cross I, and here we are talking the set R2 under standard Euclidean matrix. So whatever we know about the plane till now is it is considered in the usual sense. That is what I am trying to say. Now you see, can you write this as the union of two disjoint separated sets? Okay, can it be possible? Here we have an entire set in which we are removing only a countable number of points, but still the set is a single set, right? You cannot separate, this is separate part, this is separate part, this is separate part, this is separate part, this does not have any connection with this. Like this we don't have. So this set is a connected set, right? And when you come to the second thing, here what we have is that we have something of this set. Only this part of the set, this part of the plane is removed from the entire set. So the resultant set is the union of this part and the other part. These two are disjoint, as well as if you examine for the separateness, you will have these two to be separated, because the limit points of this set lies inside the set and at the boundary of this set, but this does not have any intersection with the limit point or the boundary of this set. Okay, therefore these two are separated sets, and the resultant set is the union of these two sets, hence it is not connected, right? And when you come to this, what are you going to have? You are going to have some ellipse of this sort. You are going to consider the interior of this ellipse along with the boundary, and this is a connected, you can see, right? And when you look for the second, that is the fourth example, you will consider the exterior of this ellipse with the boundary of the ellipse, and even now this is a single set with few points removed from it. But if you examine for the limit points are here, it is a single thing. You cannot write this as the union of two separate things, hence it is also connected, right? And here when you come to the hyperbola case, you have set of this form in the first case, right? So you are going to consider this part of the set. Here it is a single thing, it is connected, whereas this you are going to consider this part and this part. So you have two separate things, and the limit points of this part lies on this boundary, and it does not have any intersection with this part of the set, hence it is not connected, right? This is going to be what? This is going to be the upper half of the plane. It is a single set, hence it is connected, right? If you look at these things, here you are going to have only the shaded region with this boundary excluded. It is a single set now, right? Hence it is connected, whereas in the 9th question we include the boundary of this circle as well. This is also turning to be a connected. Now, be it R2 or R1 or any set, if you consider the singleton sets are always connected. Okay. In the previous lecture, we have seen that in real line only the intervals can be connected. Intervals and singletons are connected in real line, and in and in planes we have seen several examples of a connected set, and this might give you an idea of connected sets and separated sets. I hope we have come to the end of this lecture. If you have any queries, you may post it in the comment section. That will be clarified within 24 hours of time. And I would like to thank you all from the bottom of my heart, as this is the last lecture in topological concepts, and of course we are going to start a new lecture, that is sequence and series. Hope you will give your support as you have given for this lecture series. Thank you for watching. Thank you.